Okay, let's examine an example for intensity of sound waves. Here we have a speaker which emits sound with a power of 5 times 10 to the minus 2 watts. So this is basically equals to capital P, the power of the speaker. We want to know at what distance is the intensity level 100 decibels. So this is what we call beta, the intensity level of sound. Now we must start with the information given and what we choose to find. Let's start with our intensity level. Intensity level of sound is defined as beta equals 10 decibels times the logarithm of the intensity of the sound over I naught, the lower limit of the intensity that human hearing can perceive. Okay, and we know that to be a constant value of 10 to the minus 12 watt per meter squared. Now we are given what beta is. Beta is 100 decibels. That is equal to 10 decibels logarithm of I over I naught. Now from basic knowledge of logarithm, we know that if we don't write the base of the log, the base is automatically considered to be 10. Alright, this is called the base of the logarithm. Okay, so this number this log term right here has a base of 10. And we will use this fact right about in a few seconds. Now let's do some math here. Let's divide both sides by 10, so that on this side we end up with 10 decibels, and here we get 1 times log base 10 I over I naught. So the only unknown here is I, because I naught is known to us to be 10 to the minus 12. So how do we find I? We have to separate this term away from the logarithm. How do we do that? Well, we change the side of the base 10. So when you take this base on this side, the base number always remains a base. Okay, so on the right hand side it is the base of log, on the left hand side it will be the base of 10 of this number. Okay, on the right hand side it was the base of log, on the left hand side it will be the base of 10. Therefore when you replace this, when you take this 10 away on the left hand side, we get 10 in the base, which this is the base is this 10 right here, to the power of this number. Okay, so the base becomes the base and the number is elevated to being the power. I'm not going over the rules of doing this. This is for algebra exercise. Okay, I'm just taking a shortcut. If I change the base of logarithm, if I change the if I change the side of the base of the logarithm, it remains the base while the number is elevated to the power. Alright, so we have 10 to the 10 equal to I over I naught was 10 to the minus 12. Now it's just a case of basic algebra. Multiply both sides by 10 to the minus 12. So we have 10 to the minus 12 times 10 to the 10 on the left hand side. On the right hand side we have just I. Therefore the intensity that I perceive from the speaker is 10 to the minus 2 watt per meter squared. Alright, now remember that how intensity is defined. Intensity of a wave, of any wave, can be light, can be sound or anything, is the power of the wave over area. The power is nothing but energy transmitted over time. What is area? Now, waves from a speaker or the sun or any light source in general spreads out in a spherical shape. Okay, so from the source it will spread out spherically. Okay, therefore the area is the surface area of a sphere. The area it spreads over is just 4 pi r squared, the radius being the distance from the center to the boundary of the sphere. okay, just the radius of the sphere. Therefore, we have this I, plug that I in, 10 to the minus 2. Power is 5 times 10 to the minus 2. And area is 4 pi r square. Now, what is r? R is actually the distance we are looking for. What is the distance? The intensity level is 100 decibels. So when the intensity level was 100 decibels for the sound, the corresponding intensity came out to be 10 to the minus 2. We will use that intensity to find how far away from the source is the intensity 10 to the minus 2. How far away is what we call the radius of that sphere. Okay. Therefore, solve for r square by dividing both sides by 10 to the minus 2 because we can. Cross multiply both sides. 4 pi times 1, 1 times 5, and r is just 5 over 4 pi. If you take the square root, then you find the radius to be 0.63 meters. At this distance, the intensity is 10 to the minus 2 watt per meter, while the intensity level is 100 decibels. Okay, this is what we set out to find, and we have successfully done so. Hope this example made sense. Thank you very much.